there, and welcome to Dr. J's Java Modules. In this module, we will discuss Java fundamentals. So, first we should probably start a little bit with the fundamentals of computing. So, as you may recall, hardware is anything in a computing system that is physical or tangible. In other words, you can touch it. Even if you have to break into a computer case, it's still tangible, right? So RAM usually lives inside of the computing case, and so does, say, a hard drive or something like that, but they are tangible. You can touch them. Software is intangible, meaning you cannot touch it. Main memory versus secondary storage. Main memory consists of RAM modules in the hardware, and what this does for us, this piece of hardware, will give us the ability to hold variables, constants, and also instructions. A lot of people forget that, but data and instructions both live in main memory. If someone asks you how much memory do you have in your computer, if they know what they're talking about, are talking about main memory, although a lot of people misunderstand this and they think that we're referring to secondary storage. So if the power goes out, whatever's in main memory disappears. So we call this type of memory volatile. Secondary storage, on the other hand, the hardware again would consist of things like disks, and one of the types of disk would be the mechanical platter hard drive. Those are electromechanical instead of purely electric, so they are very slow compared to, say, main memory, rather. But you could also get solid-state drives now. That's a newer technology, which has no moving parts. And solid-state drives they're not as fast as RAM, but they're still much faster than mechanical hard drives. Right now, it's a fairly expensive technology, at least relatively speaking, so people have been putting the operating systems and things like that on the solid-state drives. There's also things like portable drives, like external hard drives, flash drives, CDs, DVDs. Those are optical drives, so at the end of the day, they're all encoding ones and zeros. In software, we perform file I/O in order to use this secondary storage. And the question might remain, well, why do we even bother with secondary storage if we have main memory? And it goes to the key of the power going out or you not saving something, quote unquote. It will not stay in memory because that memory, the fast, really fast main memory, is volatile. With secondary storage, we can actually persist data. And file I/O, basic file I/O, is just using actual files, but database operations would also include a type of input-output system as well. Programming languages. So, many high-level languages exist. There's the C language itself, and also C++. They're not the same language, but I put them on the same line. C++ was derived out of C when it started adding object-oriented features. So C++ is more what we would call object-aware. It isn't really object-oriented fully. Java is fully object-oriented, and so is C#. Python's actually older than Java, which is interesting. A lot of people don't know that because they think it's this new sexy language that everyone wants to learn. But Python was actually invented a couple years before Java. JavaScript is a web scripting language. It is not Java. The name was entirely based on marketing. It isn't Java. Okay, so it's a client-side, typically web scripting language, but it's also more recently than it used to be, just client-side web development. And there was a competitor at one point that Microsoft put forth called VBScript. So it's kind of a Visual Basic-based scripting language, but it did not survive very long. JavaScript is king of the hill as far as client-side development is concerned for web development and adding dynamic qualities, something they used to call dynamic HTML or DHTML back in the day, but now it's just an integral part of the systems. And the browsers implement these different JavaScript engines. So other languages would include Kotlin, which is a fairly new language. It is an alternative to Java when you're developing Android, one of the alternatives. And a lot of people have started to prefer Kotlin because it does have some nice features to it and simplistic language linguistic style and things like that. So a lot of people prefer Kotlin. And also there's a pretty new language called Dart, and it's used a lot with web development and some other independent type projects, but it's used a lot with Flutter, which is a web development framework. We also have keywords. So most programming languages have keywords, operators. We'll talk about that more in a bit. Keywords would be the words that you cannot create an identifier for because they're already reserved and could be used. Keywords are the ones that are used. Typically people use keywords and reserved words synonymously, but keywords are words that are actually used in the language to mean something special, and then reserved words may be reserved, but they may not actually be used yet. So Java actually has some words that are reserved, meaning you can't create an identifier of that type, but they aren't really used, so they're not really keywords. And then again, operators, more on that in a bit. Punctuation. So you add punctuation and syntax rules, they kind of go together. You don't want to, or you do want to add things like semicolons and stuff like that to the end as well. Programmer-defined identifiers in Java, they can start with a letter, underscore, or $sign. Inside of the name, you can have any number of letters, underscores, $signs, or numbers. You can actually have integers as well as part of the name. So if I made like tax1, tax2, tax3, or total 1, total 15, character 7, or whatever you want to put numbers throughout the name, they just can't be the first character in the identifier. You can use the $sign in the identifiers, but I would recommend you not do that because the $sign has special meaning in some other languages like PHP. Syntax rules are the grammar of the language. Violation of the grammar is called a syntax error. And by the way, I'm aware I'm not running the slideshow. I just like flipping back and forth between the development environment and the slide, so I almost always keep it in edit mode when I'm going through, even for face-to-face classes. So why would you want Java? Java is very popular. Now, there are a lot of other, quote, new, quote, sexy languages out there, but a lot of them they kind of go through cycles where they'll be really popular or not. Python has kind of rotated into the stream because of machine learning and AI and data science, and that's probably going to remain pretty popular. But there's a lot of other languages that may not remain popular for very long. Kotlin is one that everyone's really, really excited and happy about, but there's a good chance that Dart might overtake it at some point, and that's probably on the horizon. That's my estimate, but I may eat my words. Maybe Kotlin will remain super popular. Oracle and Google don't get along really well, so sometimes, there's been talk about maybe them replacing Java in the Android environment and trying to get rid of the Java virtual machine because Oracle kind of has a bad track record with suing people. But Java is still very, very popular. Java 8 is kind of ironic because it gets updated with new standards, but they still have remained calling it Java 8. And the newer versions, there's actually Open Java, the Open JDK. That one does not require any kind of commercial license or anything. So a lot of people have been using that and trying to use that more. I actually have some video on the YouTube channel about how to set up NetBeans with the newer versions of Java that are open, the open versions. But anyway you cut it, Java is still one of the most popular languages. It's in the top 3 or top 5 of nearly every survey I've seen, even within the last several years. It's cross-platform, which means that it can run on different machines, and that was one of the early appeals of Java. It's technically a hybrid language. So when you're asked, is it compiled language or is it an interpreted language, like JavaScript, you can say yes. So Java is a hybrid language. It's compiled into bytecode from the Java source code. And most of you probably know that computers don't understand source code, high-level source code. They understand the ones and the zeros, the machine code, but machine codes are really hard for humans to write. So we had to come up with these compromises and then have little programs that do the conversions for us. And Java's hybrid. So it is compiled, but it is not compiled into a native machine code. It's actually compiled into something called bytecode, and then that is interpreted by the Java virtual machine. So it's very interesting the way they went about it. The compilation process takes the code and it converts it into this kind of intermediary code, this bytecode, and then the bytecode acts kind of like a native format that's then run on the JVM. So the Java virtual machines are platform specific. You download those, so when you quote install Java, that's actually what's installed as the JVMs. The bytecode and the source code are portable, and that's what one of the appeals of Java is. So here's a simple application, a hello world application. You can see public class hello world, and then in curly braces, right here, the beginning opening curly brace and the closing curly brace, you have a method named main. So we'll look at that in just a moment. I'm actually going to pop over into NetBeans briefly, and we'll just use the default package. Right-click after you create a project. I've created a project here, which is just File, New Project. No big deal. Module, Fundamentals, Java. I'm going to right-click the default package under Source Packages, go to New, Java Class, and we will call this Hello World. Notice there is no space, and it also gives you a recommendation you put it inside of a package instead of the default package. Packages are just collections of classes, nothing magical to them. But they do help you organize your projects, and there are some reasons to use them, and if you have a larger project, it's a really good idea. Here we go. Okay. So, public static void main. There we go. And you also have this string args right here. So this is our basic program. And then you can do system.out.println or print, either one. And that's how we print. So in C++, this would be similar to like that. All right, so that's the C++ equivalent right there, if you're familiar with C++. All right, so let's look at this a little bit. So public means it's accessible outside the application. Class designates that this is a class, which is an entity within our Java application. We'll learn more about classes in a later module. Hello World is the identifier of our class, and it must be the same name as the file's name. So, for example, Hello World class over here has to be inside of the helloworld.java file. This is considered a good convention in languages like C++, but in Java it is required. If you make this a different name than the class that's in the public class that's inside of it, there can only be one public class that's an outer public class. You can have classes inside of classes, which are called inner classes, but we're getting ahead of ourselves. But whoever the outer public classes, that name has to match the name of the file. If you change it, it will not compile. Okay? So it's not just a recommendation anymore. Now, right here, if I right-click the file and then go to Run File in NetBeans, and it's a similar thing if you're using IntelliJ or Eclipse. There's a Run File also. So give it a few seconds. And first time it launches, it takes it a few seconds. So there you go. Hello World. This is just inserted into the output stream by the IDE. And this is the actual output that your code is generating. All right. So let's go back in here. Inside the class, again, is the main method. That's the entry point of the application. It has to match this signature exactly. The only thing that you can change here is args, but by convention it's called args, but it doesn't really matter if you call it sausage or whatever. It'll still run, right? See, it still runs. But args is the conventional name. If you change this, or change void, or change static, or whatever, you're going to have all kinds of problems. So public, static, void, main. All right, in C++, you have int main, and there's no access modifier in front of it. So the access specifier, the access modifiers actually go in front of every single thing inside of a class. So whether it's data, whether it's a method, each one gets this. You don't have sections like you would in C++ if you're more familiar with that language. So public means, again, accessible outside the class. Static means owned by the class, not an individual object. Again, we'll learn more about what that means in terms of object-oriented programming. Void means doesn't return a value. So how do we print to the console? Well, you just saw me do it. Print versus println are two interesting things here. So what happens if I take the ln off of print here and just leave print? There's also a printf, by the way, if you're familiar with C for formatted printing. But let's run this and see what happens. Well, that's interesting. So it still prints hello world, but this stuff that's output to the output stream by the IDE that says build successful, that is actually put on the same line. That's because this did not insert a new line character into the output stream. That's what the ln at the end of println does. It's just a convenience. And I could actually do this. So I could put \n, which is the new line escape sequence. It's considered a single character, even though it's 2 keystrokes. So if I run that, it puts it back to what it was originally. So that's equivalent. Doing print with this is equivalent to doing println without it. The other thing you could decide to do is maybe \t. That's a tab, so that puts a little extra space in between them. But we're going to take this back here and convert it back to the print line. Rerun it, and there we go. Data, as far as data is concerned, we have variables, constants, which are indicated with the final keyword, and also literal constants, so symbolic constants and literal constants. And there are data types, and there's 2 categories, which we'll get to in just a moment. So let's create another file. Right-click the package, new, and we'll say data fun. And I'm going to create another public static void main. And right in here, I would recommend also, if you're new to Java or you are rusty, is type this out over and over again. Like, you should be able to do it without the shortcut that I've been doing. So public static void main string bracket args curly brace. If you can't do that in your sleep, then don't use the shortcut. All right, so inside of here, if I say int my num, well, let's say my favorite num equals 15. That's one thing I can do. And we'll say print out the number is my favorite num. And let's right-click this and run it. And it says num is 15. That's exactly what we wanted. But let's dig down a little deeper. Int is a data type. If you're coming from C++, this is the exact same data type. And we have other primitives, of course, like double and float, and those would be the same as C++ also. But right here we have int, my favorite num equals 15. You could also separate the declaration from the initialization onto 2 different lines. So I'm doing this for a moment so we can really focus. This is called a declaration, because you're declaring the existence of the variable and saying what is its data type. So this is our keyword here, and this is our made-up name, the identifier, and then a semicolon. Right here, you have the initialization. That's the first assignment operation of a value, so you give it a value. Now you notice with Java, unlike C++ where it's just a warning, if I comment this out, it's going to give me an error. It'll say the variable might not have been initialized. So you do have to initialize the local variables in a method. If it's a class level variable, which we'll get to again at a later module, then you do not have to initialize them. They're automatically initialized to the 0 value. All right. So int is one of the data types. You could also have something like double. We'll say double my dubs equals 3.14. That's the declaration and initialization on the same line. All right. There you go, 3.14. Now, just to be clear, what we're talking about when I say constants, in a language like C++, you would use the const keyword. But in a language like Java, you actually can do this. You can say final double, like my pi equals 3.14. And then if I try to change that later and say my pi equals 3.15 for 16, it'll say that's an error. It'll say cannot assign a value to the final variable my pi. So again, if you're coming from a language like C++ or say C#, you do not want to use the const keyword, you want to use the final keyword. So that's how you make a constant. You'll also notice my naming conventions. Right here, I start with a lowercase name, and every new word, I can't have spaces in an identifier, so I capitalize each additional word. That helps it become more readable. That is called camel casing, because it looks like the humps of a camel. So we'll say for variables, use lowercase camel casing. For class names, use uppercase camel casing. I'd also say for variables and methods. Now, this one, it could be different depending on what language you're in, but pretty much everyone agrees variables should use lowercase camel casing for Java, C#, and C++. Methods, or what you would call member functions in C++, those you start with lowercase in Java and usually C++ as well. C# tends to capitalize them, but pretty much everyone agrees on the variables. Now the constants, some people don't like this and they'll just use regular old variable names. But here, for a constant, we don't use the camel casing, or I don't use the camel casing. And again, it's not enforced by the language, it's just a convention. But for constants, use snake case. Okay, so it's called snake case, also called underscore case, or underscore casing, whichever you prefer. All right, so there you go. So far, so good. There are two categories of data types in Java. There are reference types and primitives. Some books will say there's different things like, oh, arrays are different and classes are this and that. At the end of the day, there are reference and primitive types, and that's how I tend to categorize them, is the two-category system. So here's the difference between them. Primitives hold the value directly. There are 8 of them in Java. There's byte, short, int, long, float, double, char, and boolean. If you're taking a class with me, you better memorize these. Byte, short, int, long, float, double, char, boolean. Again, these hold the value directly, and that's different from reference. Anything that's not one of the 8 primitives you can think of is a reference. Okay, so if it's not one of the 8 primitives, it is a reference type. They hold a memory address of the object that we're interested in. So you don't have things like class instances and things like that living on the stack like you do in C++. Anything that's not one of the primitives lives on the heap. So for example, string, scanner, random, you'll notice that, again, if you're coming from C++, string is actually capitalized in Java because it's a class, and you should capitalize classes. Scanner, random, there's tons of others, and you can make your own, rectangle, horse, cow, donkey, whatever you'd like. But again, reference types hold memory addresses as their values. They do not hold the object. They hold a memory address. So conversions. Here's examples of conversions. There are different types of conversions. These exist in all kinds of languages, but some of the languages allow them and some don't. So for example, a widening conversion is when data is moved into a larger data type. And in this case, data won't be lost, so it's called a lossless conversion. The narrowing conversion, when data is moved into a smaller data type, the data could be lost. So this is called a lossy conversion. I usually use the example of the bucket and the styrofoam cup. And what this is that imagine that you have a friend who has perfectly good aim, and they're holding a styrofoam cup above you, and you're holding a bucket below them. They're on a stepladder or something, and you can't see what's in the styrofoam cup. Can you trust that when they dump the styrofoam cup, assuming they have perfect aim, that you will not fill your empty bucket? Can you be sure that your bucket will hold that little styrofoam cup? And the answer is yes. And that's a widening conversion. The data, the water, is moving into a larger place to live. A narrowing conversion is if your friend's holding the bucket and you're holding the styrofoam cup that's empty. You don't know how much water is in that. Now, could there be just enough in the bucket to fit in your cup, or just a few drops? And maybe instead of just expecting them to, dump it all over you, maybe they have perfect aim or have a funnel, or maybe there's a little thing on the bottom of the bucket to help put into the styrofoam cup. So we're assuming that part's okay. But can you trust that your styrofoam cup's going to be able to hold all that liquid? And the answer is no, you can't. So that's a narrowing conversion. Java does not allow implicit narrowing or lossy conversions. So if data could be lost, Java does not allow it. And I have right here a little reminder. That's what I put in these slides, is mostly reminders to keep me on track, not every piece of information known to man. That's what the video is for. So double versus float example. So if I go over here, and I'm going to actually create another file, right click, new Java class, and we'll call it conversion fun. And I'm going to put a little comment at the top, widening called a lossless versus narrowing called a lossy conversion. All right, so there we go. There's my main. And this is just a little thing I do so everyone can keep track of stuff. I tend to do that with my code, but it's entirely up to you. That's not required. So inside here, I have a double. We'll say my dubs equals 3.4. And then we'll say float. Some float equals 3.4. All right, now look what happens. You'll notice for my dubs, it's allowing it, but for some float, it's not. So if we hover over this, it says incompatible types, possible lossy conversion from double to float. So how is it losing data? I don't understand. If we look here, we've got a double up here, but here, let's comment that out and see if that helps. And it doesn't. Okay, that doesn't help. So what's going on here? I don't see a double on this line. It still says incompatible types. So possible lossy conversion from double to float. Well, I know where my float is. Where's my double? Ah, there's my double. One thing that's lost a lot in learning a programming language is that not only do variables have values, data types rather, not only do variables have data types, but values also have data types. And the data type for a decimal type value, a real number in Java, by default, is double, not float. So what's happening here is there's a double on the right side, and you're trying to put it into a float. And so even though a float can definitely hold this with no problem, because this number is small enough, it doesn't look at the actual value, it just looks at what data type the value is. And it says, hey, you could... That's why it says possible lossy conversion from double to float. You could lose data here. So the way we correct this is you could do kind of if you had a variable conversion, you'd have to do this. You could do that. But the preferred thing to do is to do that. Put an F at the end. You put a capital F, lowercase is my convention, and then double has no problem because you're putting a double inside a double. Now, again, float, my float. Same thing with the double here, my dubs. You can't put an F at the end because then it'll say, wait a minute, I don't know what that is. But here, you can do that. If you put an F at the end, it thinks it's a different variable name altogether, a different identifier that it doesn't know. So you have to do this if it's a variable. You have to convert it. Now, it allows you to do this, and you can say, I'm willing to take the risk of losing data. That's what you're doing when you're doing this conversion, but it will not allow a narrowing conversion or narrowing coercion. It's not going to allow an implicit narrowing conversion. C++ will let you do it all day long. So then again, C++ will let you, stick a fork in a light socket. It'll say, it's, like your dad when you were a kid saying, he'll learn. let him do it once. Okay, C++ kind of acts like that. C++ will let you make all kinds of mistakes and won't really give you anything but maybe a warning. Java does a little more hand-holding in some ways. That doesn't make it a weaker language. In some ways, it's very, very powerful, and it matches up to C++, especially in recent years. It's very close efficiency-wise, which is something no one thought would happen, but they've made it better and better all the time. And it's often very productive, sometimes more productive. So it's a good language. Comments, you probably already know these, but single-line comment, 2 forward slashes, multi-line comments. These are the older style comments, sometimes called C-style comments. You can put /*, */. Usually when I have someone turn in a program, you'll notice Java actually automatically gives you a matching pair. I'll just put some sort of information here, CIS, 1 million or something. Okay, so you're taking this class, and then you would put maybe the date or something like that. So 8/7/2020, or what have you. Okay, so far so good. Now, next thing up is operators. We have 3 different major categories of operators. Now, there are operators that fall outside these categories. There are several, but these are 3 of the big categories of operators. There's arithmetic or arithmetic operators. These are used with numeric types in Java. There's no operator overloading in Java, so if you're coming from a language that allows that, you can't do it in Java. You use methods instead. So if you want to add 2 rectangles together, you can't overload the plus symbol to say, what does it mean to add 2 rectangle objects? So there is no such thing as operator overloading in Java. So arithmetic operators are for numeric types. Relational operators are used to compare numeric types, and you can also use the equality operators, which are sometimes considered a separate grouping, but I generally group it under relational operators, the equal to operator and not equal to operator. Those can be used with any type. But when you compare references, what are you comparing? You're not comparing the object, you're comparing the memory address, because that's what references hold. And then you have logical operators. These are used to combine Boolean expressions. So most of this, again, if you're familiar with the languages, Java or C++ or C#, this should be review. The arithmetic operators, plus, minus, multiplication, division, and modulus. Modulus gives you the remainder of a division problem. The compound operators, every single one of the arithmetic operators has a corresponding compound assignment operator, such as plus equals, minus equals, times equals, divide equals, and modulus equals, and also the increment and decrement operators. All right, so plus plus or minus minus. Relational operators, no surprise here. We have greater than or equal to, less than or equal to, and then the subgroup equality operators is equal to, is not equal to, and the logical operators. These are truth tables. You should be familiar with them, and if you're taking one of my classes, you need to be able to replicate these very easily. This could end up on a job interview, but it definitely would end up on something like a test. So you've got any variable P and Q, P and Q, P or Q, and then not P. Oops, that shouldn't even be a Q there. Sorry about that. I should just say not P. Not P. So copy and paste error. Now what you see here is you've got 2 trues equals a true when they're combined with and, but otherwise it's false. So both operands, the things around the operator, both operands, need to be true in order for the whole thing to be true when and is applied. With or, as long as at least one of the operands is true, the whole operation yields true. So the only time this is false or false is false. And then we have a unary operator over here. This is just reverses its operand. So not true is false, and not false is true. So again, unary and binary, that's one way to classify operators. If we go back briefly to arithmetic operators, The increment and decrement operators are great examples of arithmetic operators that are unary operators because they only take one operand, like plus plus a, x plus plus, c minus minus, my num minus minus. But then you have the regular or compound operators. These are binary operators because they take two operands. Okay? All right. Next thing up, we've got user input. So to do user input, perform user input in Java, you need to use the scanner class, java.util.scanner. So you import the, java.util package, and then scanner is a class within that package. So this part's the package right there. So we'll just say java.util package, and then we'll say import java.util.scanner. There we go. That's better. Makes a little more sense this way. So this right here is a class that lives in this package. It does not change the efficiency. It actually makes it just so that you don't have to type certain things, which we'll get to. But we use system.in. That's the standard input object, and it corresponds to the standard output object, which we've used. So let's try an input example. So right here, we'll call it input fun. And at the top, outside of the class, I have to put import java.util.scanner. So this is a utilities package and .scanner. Okay, public static void main. Sorry, here in main. And we're going to make scanner keyboard. And then keyboard equals new scanner. And then you pass in the argument system.in. Now, you could put this on one line, but I'm separating it for a reason. This is the declaration of the keyboard, and then this is the initialization right here. So here's a question I'm going to ask, and I want you to try to think about it for a minute. Maybe even pause the video and think about it. Scanner keyboard, that's the declaration. And then right here, keyboard equals new scanner system.in. That's the initialization. The first time it's assigned a value. So my question is, when I put scanner keyboard, do I have a scanner object? So before this line here, I'm talking about just this line. Immediately after this line is executed, do I have a scanner object named keyboard? So think about that for a minute. And here's the answer. The answer is no. You do not have a scanner object. No scanner object yet. What do we have? What do you have? Only a variable capable of holding. What are we holding? The address of a scanner object. But right now, it doesn't have an address assigned to it. So you do not have an object yet. This is not like C++. So it's actually more similar, if you're coming from C++, this would be more similar to a pointer. Similar, not exact, so you'd have scanner pointer. But it only holds a memory address. It does not hold an object. This right here, the new keyword, returns the address after it calls the constructor of the scanner, and this constructor expects an argument. Right here is the argument, system.in, that is the standard input object. So that's how you initialize that. Now what happens if I say string, we'll say name, and then also maybe we'll say int age. There we go. So let's use the scanner for this purpose. So we have please enter your name, or let's say, yeah, please enter your name. And we're going to say name equals keyboard dot next line. So that's how you get a string. And then we'll say please enter your age. And then age equals keyboard dot next int in this case. And I can print out hello, and then you can concatenate this way. I can say hello name, and then I'll say you are, and then age years old. So let's run this and see what it does. So when I run input fun, it expects me to type something, and then we'll say my age. We'll go with 22, because that sounds like a cool age for me. And then it says, hello, John, you are 22 years old. I wish. All right, so when we go back up here, we see that we've declared our keyboard, but it does not have an object. There is no object associated with it. It's just a variable capable of holding an address. This right here receives the address, and you might think, if you're coming from a language like C++, wait a minute, don't we have to delete the scanner because we're done using it? The answer is no. You do not have to call delete on keyboard later on. So in C++, you'd have to do something like this. You'd have to say like delete scanner, or well, delete keyboard. But we don't have to do that in Java. In fact, you can't. Java has what's called automatic garbage collection. So unlike raw pointers or regular pointers in C++, you do not have to keep up with deleting the objects or returning the objects that you have allocated on the heap. So, and in case you're wondering, if you are, again, interested in C++ or taking it or have taken it before, there is something called smart pointers in C++. It's a newer feature. It was introduced in C++ 11 standard, and it allows you to create these pointer-like objects that manage their own memory and return it when they're done. So you don't have to delete those either. But it took them a long time to catch up with Java, which has had this built in from the beginning, since the 90s. So we're talking over 20 years, almost 20 years. All right, so this is what we have so far. Now, there's another thing that may pop up that I want you to be aware of. So let's do this. Let me think here how we're going to do this. We'll say int, we'll just call it fave number, and then string city. This is going to be kind of interesting, and you've probably seen this happen in another language or in Java before. So let's say enter your favorite number, and then we're going to get favnum, and then we're going to say enter your city, and then we're going to say city equals keyboard.next. You'll notice there's a ton of other options. So if you need to get a double or a float, a long, plenty of different types, right? And even you can filter with regular expressions, all kinds of options. But for right here, we just need next int, or sorry, next line, because that's a city. And let's see what happens. Let's see if this actually is going to do what we think. So we'll say favnum is favnum, and then we'll say city is, and then we'll say city. See what that looks like. All right, so the first two are good. John, and then we'll say again 22, of course. Favorite number, let's see, my favorite number is 180. And I hit enter, but it doesn't ask me for well, it says enter your city, but it doesn't give me a chance to enter it, and it just leaves it blank. So what's going on with that? What's the problem there? Well, the issue is that when you ask for an integer, it does not consume the new line character when you hit enter. Next line does. So what happens here is when you enter that number, 180 or whatever your favorite number is, and you hit enter, the enter is still living in the input stream. So you think of this as a stream going by and someone fishing. That's what the scanner does, is it fishes, finds stuff, and then returns it to you, puts it in your tackle box, your bucket over here. So it grabs the string, it includes the new line character, so it clears that out of the stream's empty, and then when they enter a number, it comes along, you grab that, and then you throw that into the bucket. But guess what? After you entered the number and hit enter, you, by hitting enter, input a new line character into the input stream. And what happened? It's still in the input stream. Now down here it's not a problem because this one ignores the input stream, but what's going on when it gets here? Well, unfortunately, there is still a new line character living in the input stream. So we have to consume it. So keyboard.nextLine, consume new line character. And I think we're going to have to consume the other one, but let's test this first. Okay, John, 22 and 180. And, oh, I guess not. Okay, so I guess it consumed both of them. So enter your city, Dearborn. So it's waiting on me now. Oops. So before you ask for a new line after you've asked for, or a next line rather, after you've asked for a number or anything that isn't a string, you should also call this, even though we're not setting anything equal to this, because we don't really care to store that new line character, we have to remove it from the stream. And this is not a Java specific thing. If you've used C++, this might have kept you up until 3 in the morning trying to figure out what the heck's going on. It's actually ironic because it's 3:30 a.m. when I'm recording this, because I'm a night owl. I usually wake up when everyone else is going to, or go to sleep and vice versa. All right, so here we go. And, very quickly, I guess we should reiterate this. System.out is the standard output object representing the console. And then system.in, which we use the scanner with, represents the standard input device, which is usually the keyboard. So keyboard entering data into the console, pulling in the data from that stream. All right. The next thing up, which is an important thing for you to understand, are control statements. This gives you a ton of power in any programming language. And in general, we can categorize them in 3 different categories: sequential, selection, and repetition. Sequential, I'm going to say within a given method. Sequential is when the lines are executed in sequence. This is the default. There's no branching or making a decision or taking one path or another based on what the input is. That's not part of the sequential or sequence control statement, depending on who you're talking to. So sequential or sequence control means you're not really making any decisions or repeating anything. Selection means you're choosing to either do something or not, or choosing among different options. Maybe between 2 things, among 15 things, or just saying I'm either going to do it or I'm not. And then repetition would be repeating a code block. And then selection and repetition are both based on some sort of condition. The repetition control statements will be based on what's called the loop continuation condition. So under selection, we have sequential is not really required to cover again because it's the default. It's basic. It's what we've been doing so far. But under selection, there's 3 different options. You've got if, which is single selection, means if something, that means you either do it or you don't. So you can do what's in the block or don't. If else is double selection. That means you do this or you do that. You can also chain them or nest them. So you can say if, else if, else if, else if. And that can simulate what's called multi-way selection. Okay, so multi-way selection. And then you have switch. Multi-way selection control statement. It's built in. It tends to be less flexible. It's not good with ranges in Java. Some languages like, Swift, you can use ranges with switch statements, but it's really not appropriate in Java. It's not good for large ranges. But with switch, you have multi-way selection control. Cases fall through without a break statement. And the default is kind of like a trailing else on a bunch of if-elses or even just one set. And then finally, repetition. There are 3 types as well. There's actually there's a second variation on the for loop, but we'll get to that later in the course, later in the modules. While is you continue until a condition is no longer true, and this is a pre-test loop. Do while, you execute the loop and then test, so that means it's a post-test loop. This is what I call the reckless younger brother of the other repetition control statements. And then you have the for loop, which is another pretest loop. This is perfect for counter-controlled repetition. And if you remember, you probably know that there are 2 major categories of repetition. There's the counter-controlled, where you have literally a counter controlling it. And then you also have sentinel control, which means you're waiting for a particular signal. So someone inputs a specific value to say, hey, break out, or reading until the end of a file. That would be a sentinel-controlled repetition. So let's do a little short example with some control statements. Again, I'm under the running assumption that you have some programming skill watching this and you've used it before. used Java or C++ before, but we'll say control statement fun. And right here, public static void main. Let's do this. We'll actually import java.util.scanner. And I'm going to say, let me see here, scanner keyboard equals new scanner system.in. And then we're going to say int age. And let me see what else we're going to do here. Yeah, I guess that's good. We'll say first, print out what is your age, and then age equals keyboard.nextInt. Perfect, so we get the age. And then what we're going to do is we're going to say if age greater than or equal to 21, else, so end if else, we'll say here's a Coca-Cola, and then above here, if they're 21 or over, here, have a beer. Okay, not that I'm encouraging you to drink beer. I actually prefer Coca-Cola, but that's just me. All right, so let's run this, and it's making a decision. When we say 15, it will say here's a Coca-Cola. But if I say 21, it'll say here, have a beer. Now we can extend this, and the order does matter. I can put else if age greater than or equal to, let's say, I used to be able to say 18 and offer a cigarette, but now it's 21. Not that you really need a cigarette, because that's just nasty. Okay, so here we go. We got age greater than or equal to 16. Here's your driver's license and a Coke. So you get a drink and your driver's license. Maybe your voting card for 18. So anyway, let's try this. Let's say they're not 21 yet, but maybe they're 19, and it'll say, here's your driver's license and a Coke. Okay, now what if it's under 16, so 14, here's a Coke, right, Coca-Cola, and then if it's maybe 30, here, have a beer. So there's different options here. Pretty cool. Now let's do control statements fun 2. This one we can just say repetition fun. I should have called the other selection fun, I suppose. And right here, let's say int counter equals 0, while counter less than 10. There's the while loop. And we're going to have to remember to do counter plus plus. We're going to print out the counter. Counter is at each step, right? And then we're incrementing it to go toward this terminating. That's called the loop continuation condition. Let's run this. And there we go. We count all the way from 0 all the way up to 9. When it gets to 9, it will say 9 less than 10. That's true. Prints out the 9. This becomes, the counter becomes 10, right? So this again is shortcut for counter equals counter plus 1 or counter plus equals 1. So those would be all equivalent. This is just so common, it's a shortcut. The other thing you can do in NetBeans and most IDEs, if I do control /, I can actually toggle this back and forth with comments. So I'm going to comment that out, and I'll show you for loop is pretty easy, right? This one, everything's in the header, so it's easier to remember in some ways. And usually we don't name this anything complicated. We usually use I, J, K, simple letters. But other than that, you should come up with good variable names for things. So I is, and then we will run this. And pretty much the same thing we got before, just with I instead of counter. Do while, the only difference between that and while is the do while's guaranteed to execute at least once. So that's pretty much the only thing that's different. All right. So that's pretty much it for this module. I hope that was useful to you, no matter what you're doing, and I'll see you later.